Okay, so in the video lecture for this week, we are going to be talking about the skeletal system a little bit more in depth. So we had covered some information in our first conversation and didn't quite cover half of the packet as far as if you just look at the number of slides, but as far as the amount of information that we covered, we're about halfway there. So um, we went through the parts of a long bone, and there was a lot of information in there that for a lot of people is fairly new. And so I wanted to hold the lecture to just that content and then come back with some of the other material that takes that information to the next level. So you are still working in that same packet that you would have received in class the other day. And the slide that you're going to be looking at is the one just after parts of a long bone. So you are looking at compact bone. And the structure of compact bone, remember, this is the section of bone where the cells are mature. They have migrated from those growth plates at the end and are starting to make their way down the diaphysis, or the long part of the bone. And as they migrate away from the growth plates and toward that center area of the bone, they start to get packed together. And because they are getting packed closer and closer, you don't have the holes or the spacing between the bone anymore, or the bone cells. And because they are so linked together, we refer to that as compact bone. So what we've done with this particular image that you're looking at is we've taken a bone, and at the top portion of that picture, they've cut the bone in half, and you are looking at the femur as a cross section. And you can see that there is in fact a hollow space or an opening through the core of your bone. And in that area, you would have bone marrow, which they don't show in this particular view. And then you also have your blood vessels. So you have arteries that are moving into the bone, you have veins which are bringing material out of the bone, and then you also have a nerve in there as well. So all of those things that need to serve living tissue are part of your bone structure, and a lot of them are going to be located in that central portion of your bone. Now, the picture that you have off to the right, what they've done is they have taken, and if you look at the very top, you can kind of see a triangle that's been drawn. They've taken that very top portion of the cross section and they've blown that up so that you can see it a little bit more in depth. So what we're really looking at is we're looking at how these cells are put together to make up your bone tissue. Because if I asked you guys to put a word to your bone tissue and what you think of when you think of bones, most people are going to think of strength. This is what gives our body its structure. It's what gives it its strength. And that all stems from that image right there and showing you how those cells are put together to provide that strength. So one of the things that, and sorry, one last one, the picture that you have at the very bottom, so that round picture that they have, again, blown up out of kind of that pie or that triangle cross section that they did. Now we're looking even deeper into the bone tissue, and we're getting to a very small number of cells. So you'll see they don't take on the traditional shape of a cell. So we think of cells being round. But what you're looking at is you are looking at 5 columns of bone cells. And we'll get to that makeup here in a little bit. So if we look at the terms that we have on the left-hand side, it talks about the osteon. Now, the osteon is if you were to take out one of those circular columns of your bone tissue, because if you look at that cross section, that triangle shaped portion, one thing that most people are able to kind of pick out, and this hopefully ties back to when we did our tissues, one of the defining features of your bone tissue is that you could see these concentric rings in the tissue itself. And so now you're seeing it again. And if you look at just one of those cluster of rings, that is what we call an osteon. Now, if you guys have ever seen a target, if you've ever played darts, anything like that, you are familiar with that concentric ring configuration. And that's essentially how your bones are put together. There's a small ring, there's a larger one on the outside of that, and again and again and again, and you just have this layer of circles that are all bundled together. Now, what happens is that osteon is going to be put right next to another osteon and another one and another one, and that is going to eventually build out your bone. Why do we have that set up? Because nothing happens by chance. So this is where we equate that strength. Because of how those cells are designed in that circular formation, and if you know about architecture, one of the strongest structures that they have in architecture is the arch. Well, if you look at that layer of concentric rings, you have that rounded formation that you would see in an arch as well. When you layer that together, layer upon layer, clustered together, is going to in part provide that strength. The other part of that strength is going to come from the minerals that make up your bone tissue. So if I say calcium, right away, you guys will put that calcium as being a mineral that we associate with bone health, and we'll get more into that a little bit later as well. But that concentric ring formation, very important, and that layering process and then bundling all of those osteons together, that is exactly what gives your bones the strength that they need. Now, if you look at the very core of the osteon, you'll notice that there is an opening. So kind of where the bullseye would be, right at the center, that is where your central canal is located. And if you look in there, that's where you're going to find that nerve. That's going to be where you find blood vessels. So it's not just in that medullary cavity, that very central portion, but within the compact bone as well, you will have smaller areas, those central canals, which are going to provide additional space for blood vessels and nerves to run through the bone tissue. So the osteon, one whole collection of circular layers. At the very core of an osteon, you have an opening for blood vessels and nerves to run through, and that is your central canal. The next one that we have is the perforating canal. And perforating just simply means that you are going to have these tunnels, essentially, that are going to link one central canal to a neighboring central canal. So because they run across, they are given the name of perforating canals. So they punch through the bone tissue, like I said, and these would be going horizontal, linking two different central canals together. When you look at your perforating canals, anything that runs horizontal is going to be your perforating. Anything that runs vertical is going to be a central canal. So that's how you can distinguish between the two. The next one that we have on the list is the osteocyte. Now, I'm going to hold on the osteocyte for just a second because I want to kind of build up to that a little bit. The term lamellae, if you look at lamellae, if you really focus on one of those osteons, you'll notice, as I already mentioned, that there's layering of rings. So a small ring around the inside and then larger rings as you move out. If you were to focus on just one of those rings, just take one out of that whole cluster, an individual ring by itself is called a lamellae. So put them all together, osteon, if you have just one, then you have, or you're looking at the lamellae. Now, one of the things that we have with bone tissue, and again, going back to tissues itself, bone fell into the category of being connective tissue. Now, in order to be classified as a connective tissue, there's a very specific setup that you have to have with the cell structure. And your connective tissues, the cells are what we call in a matrix, meaning that it's designed in a way that the cells themselves do not come in contact with each other. So the tissue is designed out so that there is individual compartments for the cells to be housed in, and those individual compartments are going to essentially separate the cells from each other. Now, a lot of people, again, don't have a huge amount of background with the structure of bone tissue. So the best example that I can give you is to think of an apartment building. If you think of an apartment building, you have all of these units in the apartment building where people live. So how do you get to your floor if you live on the 10th floor? More than likely, you're going to take an elevator. Elevator would be equivalent to the central canal because that's moving you up and down. Then you get off your elevator, you've got to get to your actual apartment door. Now you're going to be moving through a hallway. Hallways run horizontally. That would be the equivalent of a perforating canal. Once you get to your apartment and go in, that is your specific location. And you go into your apartment and there's walls that are going to separate you from your neighbors. That's what a lacunae is. So within the bone structure, there are essentially these walls that create this little pocket, and your bone cells are plugged into that pocket. Now, if you were an apartment building, it's your apartment. That's how we would refer to it. That is the space that you have, and you are the individual that is in that apartment. In a bone, we call the apartment a lacunae, your own individual space, and then you would be the equivalent of the osteocyte because you are the living thing in that lacunae or that apartment. Bone matrix, we already talked about that. Because of how the walls are set up, or those pockets, those lacunae, once an osteocyte, a bone cell, is plugged into that lacunae, that is going to then have its own space. It's not going to come in direct contact with another osteocyte. That is where the matrix design comes in, okay? That the cells are separated from each other. They don't touch each other directly. Now, the trick is, even though these bone cells don't touch each other or don't come in contact with each other, they still have to have a method of communication. The entire human body runs and functions on the ability to be able to communicate. So your brain needs to know what's going on in your stomach so that it knows when you're full and can give you the message to stop eating. Your pain receptors have to be able to send messages to your central nervous system so you know when you're experiencing pain so that you don't do any further damage to your body. Likewise, your bone cells need to be able to communicate with each other. So even though the osteocytes are plugged into these lacunae, they're not in direct contact with each other, their method of communication is going to be the caniculi. Caniculi are tiny little tunnels, essentially, that are going to link bone cells to each other. So if a bone cell produces a particular product and releases that, if it gives off a certain hormone and releases that hormone, it can then diffuse and move through those caniculi to the neighboring bone cells so that they know exactly what's going on with the bone tissue. So it's just a way to create or provide communication between the individual bone cells that you have there. Now, we already talked about the different types of bone cells, and I mentioned the other day to keep in mind that this is not even really the tip of the iceberg as far as bone cells go. These are the basic ones, your immature bone cells in the osteoblasts, the osteocytes, which are osteoblasts that have grown up. So the only difference between osteoblast and osteocyte is time. So when you were a newborn, okay, you were first developing, that's the equivalent of an osteoblast. And as you mature and grow up, transition into an adult, that's what an osteocyte does. But they are one and the same. They're just at different levels of maturity. The osteoclast, remember, that's the one that has the digestive enzyme, allows it to break down any damaged cells and basically reshape them, especially if you have a bone injury, a bone break, so that you can essentially file down those jagged, broken cells and create a space where new bone material can come in and repair that break. And then the osteoprogenitor cells, those are your stem cells. If you look at all the different types of bone cells that are out there, the osteoprogenitors can eventually become any of those. So the divisions of the skeleton, we talked about this a little bit in the introduction. And with this particular slide, if you look in your textbook, it's done in color to show a little bit better the difference between the two divisions of the skeleton. On your paper, it's basically light gray and dark gray, but still there's enough of a contrast between the grays that you can decipher which is indicating your axial skeleton and which is your appendicular. Axial skeleton falls on the axis. If you think about where the axis of the earth is, runs right through the center. And so the axial skeleton is going to be anything that really comes in contact with that central bone structure of the vertebral column. So you have the skull, you have the spine itself or the vertebral column, and then you have the rib cage. That is all going to be part of your axial. Appendicular skeleton, on the other hand, is going to be those appendages. So you're looking at your arms, your legs, but then it's also going to include